Hi, everybody. My name is Max, and I'm a member of the Multnomah County Services Directory Capstone team here at PSU. And today I'm going to be sort of giving a brief explanation of what our project is, as well as a short demo. So the project description. The problem that we are trying to solve is that Multnomah County offers a huge variety of services, both internally and externally to the community, and currently don't have sort of one location where people can go to find information out about these services. So what do we have to do to fix the problem? First, we need to define what a service is in software. Second, we need to create a centralized location for services, somewhere that they can be stored. Thirdly, we needed to populate the database. We do this with some Python code that scrapes information about services out of PDFs. And finally, we needed to make the database accessible via an API. We need to provide functionality so that users can search for services, so they can store new services in the database, and they can update services that are already in the database. So now we're going to do a quick demo. So what I have on the left side of my screen here is the adopted budget from Multnomah County. Now this budget consists of a ton of different program offers, and these program offers often describe services. There's 2 PDFs total, and our Python runs through each of these program offers and uses the information, the pertinent information there to populate our database. So we're just going to find a random program offer, facilities interiors group. And then we'll hop over to the right-hand side of my screen here, where we can see the sort of the Swagger version of our API. The Swagger is a documentation tool. It's automatically generating, and it's also interactive. So here at the very bottom, you can see the schemas for all the different tables in our database. Here's what a service has. Here's what a location has: an address, a building ID, a room number, etc. And then these are all the endpoints that our API has. So you can get services in a huge variety of ways. Today we're going to be using name because it's the easiest. So facilities interiors groups, I'm just going to type that in here. And if we hit execute, we should get a 200 code, which means success. And we should get one service back, facilities interiors group. And the description should match here. Program coordinates the movie. Yeah, so we look good here. So what I'm going to do now is I'm going to copy and paste this JSON into put. We use put because the service is already in the database. And we're going to have to do a little massaging of our JSON here, because not all of the information that you get out of a get is relevant in a put. And so what we're going to do is we're just going to change the service description. And if I hit execute, we should get a 204 code. Yep. And now I can prove to you that our database has successfully updated. I'll get by ID this time. I believe it was 86. Facilities interiors group, hello Capstone. So this is a really, sort of brief overview of what this program does. And now I'll hand it off. Thanks, guys.
Hey there, my name's Blaine Holbert. I'm going to be going over the responsibilities over the course of our project. If you want to put a face to the voice, I am the guy wearing the red and white flannel in the first picture in the picture on the first slide, excuse me. Before I move on, I do just want to say that the names listed on these slides are not in any order of merit. They're just simply in alphabetical order. So with that said, let's get right into it. First up is endpoint validation, which was done by Hanyang Xiao and Mohammed Alsaid. Endpoint validation ensures that the data that gets received by the put and post endpoints meets the API's expectations. For example, you can't pass a string into a field that expects an integer, and a call won't actually happen in that situation. The validator spits an error out at you. The program offer parser is up next. Hanyang Xiao and Max Smiley and Scott Patterson all put together this one. They developed a Python script to parse program offer data that came in the form of PDF documents, translated those PDF documents into JSON, and then JSON was used to suss out what a SQL script needed to be to initialize a service in the database. Schema development's up next. This was the responsibility of our illustrious team leader Gabriel Edwards and Scott Patterson. They developed the actual database schema that holds services for our API. This required a lot of conversations with Multnomah County about their existing knowledge of their services spread across their websites. So the create and update endpoints. This one goes to Carson Cook and Max Smiley. They developed the endpoints that create new services and update existing ones. These are the put and post endpoints that the validators validate. Next is the Swagger documentation. This one goes to Hanyang Xiao and Mohammed Alsaid. They utilized the Swagger C# framework to automatically document endpoint functionality, as well as provide a very simple interface to interact with the API on actual production data. Search endpoints. This one was from yours truly, Blaine Holbert. I developed some endpoints to search for services. So if you want a service that is specifically offered in Spanish, you can do that. Endpoints use DTOs. This one goes to myself, Blaine Holbert, and Carson Cook. We implemented a data transfer object class that allows for some abstraction and encapsulation of the data model rather than just returning raw instances of the data model. And then finally, unit tests. As you can see, this one actually goes out to every single member of the software engineering team because each individual feature of the API has at least one unit test that verifies that the feature works as intended. And then we have our team lead, Gabriel Edwards. He established the standards and practices for the development team and collaborated with the sponsor to define project requirements. So this includes defining our Git flow, creating tickets for each sprint, and taking part in a back-to-back conversation with the sponsor to get feedback on our progress.
Hi, my name is Carson, and I'm going to talk about the assumptions and constraints for working on this project. So in the first place, our assumptions were that Multnomah County would be building a front end for the API once we completed our portion of the work. We also were operating under the assumption that the database would be managed by mostly non-technical Multnomah County data stewards. The major constraints we were working under were that we needed to use a SQL database and we needed to implement this API using ASP.NET. We also needed to make sure that our implementation matched the Multnomah County API standards that were established in other projects. As for our tech stack, we used ASP.NET Core Web API for building the API project. We also used in doing so, we used C# and Python 3. We also used Swagger for the API documentation, PDF Miner for scraping the services description forms that we were given access to. We also used SQL Server and SQL Server Management Studio for building the database, and we used Visual Studio to build the project and also for creating project files that Multnomah County engineers could use. Most of the team had not worked with an API before in any capacity and had largely not used any of these technologies before.
Hi, I'm Mohammed, and I'll be covering the features offered by our API. So our API supports multiple features, the first of which is a parser program that gathers information about services offered by Multnomah County into one place. So Multnomah County has large documents that describe services. We wrote a parser designed to scrape the information from those documents, then insert into the database as seed data. The second feature is search requests. We want to offer the user the ability to search the services that the parser found. So the API supports Git endpoints through which the user can search for a service by its name or by its associations, such as the language that the service supports or the building that the service is offered in, and so on. Furthermore, we wanted to give the user control over the existing data within the database. And that's where post and put endpoints come into play. Clients can use these endpoints to create new services or update existing ones. The fourth feature our API supports is a self-documenting user interface. This offers both future API developers and users documentation to learn about the API and how to interact with it. The last feature is authorization. So per our client request, our API is not open to the public. Therefore, only authenticated, authorized users can access it. It is also configured so that it can be easily added to multcodes, microservices without any inconsistency issues. And lastly, follow-up work. These are features that if we had enough time, we would have liked to implement. So we want to implement a front end that uses the API to assist data stewards to manage data. We also would have liked to utilize natural language processing to empower searches. That means we would use the client's input to see if there is anything similar to it within the database instead of using substring comparison or finding an exact match.
Hello, my name is Scott Patterson, and I worked on the data design portion of this project alongside Gabriel Edwards. For this project, the database was very important, and our team was responsible for translating Multnomah County's business logic around services into a schema that would work in tandem with our API. To accomplish this, we met with Multnomah County representatives multiple times to discuss the layout of the database, including data models and relationships, and how to make data retrieval work best for their needs. Over time, these meetings gave us a better understanding of how the database will be constructed and how Multnomah County Services function as a whole. Before we organized the data, we needed a schema, which is a layout of our database and shows how the different pieces of stored information relate to each other. To represent these relationships, we needed a series of keys, known as primary keys and foreign keys, on each table. The main table in the schema is the service table. Each service in this table has related data, such as a contact you can reach to acquire more information about the service, or a location, such as a building where the service is held. We had to represent these relationships in our schema through foreign keys, as they serve as a gateway to definer sets of data in the database. Examples of these types of relationships are program ID and department ID in the service table that serve as a link to their respective IDs in the program and department tables. We also set up constraints in each table that will serve to preserve data integrity by using the unique and not null attributes. This would help the database remain consistent and prevent mistakes upon data entry. Another table is a location table, which we considered splitting up into multiple tables, such as having a table of building data. This building table would have had data such as room number, floor number, and building ID. But issues arose around the fact that we didn't know if any of these services could be held at an outside location, such as a park or a public transit space. If a location could be outside, then having a separate building table would prove to be too complex and possibly introduce errors. Upon further discussion with Multnomah County about this issue, we deemed that splitting the table up wasn't necessary, and we combined the building data back into the location table.
Hi, I'm Hanyang. I'm here to talk about our development process. Our sprint is once a week. It usually starts on Monday and ends on the next Monday. Before each sprint starts, team leader prepares all tickets for this sprint in advance and assigns them to the team at the start of this sprint. In order to complete the work more efficiently, we often finish the ticket in pairs so that we don't have to worry about someone not very familiar with this ticket. To avoid conflicts between codes and to manage our code more effectively, we use Git flow. After tickets are assigned, we create our own branch named feature/issue plus the number of the issue. Once we feel like the ticket is done and all required tasks are passed, we will create a pull request and this branch will be merged into develop branch if it has no merge conflicts and be approved by the rest of the team.
Hi, I'm Gabe Edwards, and I'll be talking about a couple challenges we had in this project. The first challenge we faced was parsing the program offers provided by Multnomah County. When you convert them from PDFs to straight text, you get a lot of inconsistencies like random new lines, random whitespace, and fields present in some offers but not others. To get past this, we made the parser extremely customized to the specific PDFs we were dealing with, so we get 100% accuracy on the information we parsed and ultimately seeded our database with, but the parser is not intended to work with any other PDFs. Another challenge we had to face was defining a service. The sponsor could offer some general attributes a service might have, such as location, department, but we had to translate those attributes to tables on a schema and ask a lot of questions along the way, such as can the department have a name? If so, is that a required field? Can a service have many locations, or is it tied to only one? It took several weeks of presenting a schema in the Multco, getting their feedback, interpreting that feedback into a new version of the schema, and presenting it all over again. That iteration paid off though. Not only do we have this API now, but Multco has a much stronger definition of what a service is. Big shout out to Multnomah County for sponsoring this project. They were truly awesome to work with, and thanks for watching this presentation.